This episode is sponsored by Honeybadger. Are you looking to enhance clarity in production without a PhD in observability? Try Honeybadger Insights. Honeybadger Insights is built around structured events and Honeybadger's new query language BadgerQL, which allows you to analyze data, create metrics, and design custom dashboards. All of this is available for free with Honeybadger's monitoring suite, which includes error tracking, uptime monitoring, and more. Explore your data in new ways with BadgerQL. It's pretty cool and simple. So give it a try today at honeybadger.io. That's honeybadger.io. In this episode, we're going to have another look at deployments. However, this time it's going to be a little bit different, because we're going to take more of a kitchen sink approach to this where we have many different things. So the first thing that you'll see here is that we have the concept of background jobs. So we're going to be able to process jobs in the background, and we're also going to be using broadcasts. So this is typically not something that you want to do where you're broadcasting the current time. However, in this case, I think it's a pretty good example because we're going to have a job that broadcasts out every single second the time. So again, it's not a great example and definitely not something that you want to do. However, it's a good illustration in this case. Then also, if you take a look at our server here, we have this IP address. So I'm going to refresh the page. And when I refresh the page a few different times, you'll see that it's bouncing between two different servers. And so what we're going to be doing is building a load balancer as well. When we go into our posts, you'll see that we have a picture of a cat. And this is uploaded through ActionText. So we're able to come in here, we're able to grab a screenshot, we can copy this, and we can paste it in. And when we save our record, we now see that we have both the images. And so with this, we're also going to be using ActionText, and with ActionText, we're also going to be using ActiveStorage. However, instead of using AWS, we are going to be using MinIO, which is a S3 compatible storage solution. And finally, have a look where we are using a fully qualified domain name as well. So we have this domain name pointing to our load balancer, and that load balancer is then balancing the traffic between the two different servers. And so the great thing about this is that we're going to be using Kamal to pretty much deploy everything. And we're going to be deploying it to our own servers. So here, I have a server, and this server has a lot of RAM. It has 93 gigabytes, and it is an Intel Ultra 155H. Which is a modest processor. So this isn't a beast of a machine or anything, but it does have an NVMe drive. This hypervisor is a product called Proxmox, which I really do like. I've been running Proxmox for about 10 years, and it's one of my favorite hypervisors simply because we're able to create virtual machines, which a virtual machine is just like you would get with an EC2 instance, where you basically get full access to this virtual machine. And you can use like a Windows ISO or a Linux ISO, or we can create an LXC container. And an LXC container is very similar to a Docker container, but it's also very lightweight. So the overhead is very minimal compared to a normal KVM or virtual machine. And so we're going to create 8 different servers on this one hypervisor. Our first server is a Cloudflare D service. And basically what Cloudflare D will do is the user will come into our network through a web address, and that web address will be behind the Cloudflare tunnel. That Cloudflare tunnel is a box that will sit on our network, and it'll make a request out to Cloudflare, and Cloudflare is going to be our DNS for this domain. So this way, on our home network, we never have to open up a port on our firewall. Instead, this Cloudflare tunnel will initiate the connection, and all of the traffic will get proxied through there. Within Cloudflare, we basically have the IP of our load balancer set up. So the load balancer will take in the incoming traffic, and this is going to be our load balancer. And it's then going to send it off to one of two different servers, which we have our app 1 and we have the app 2. We then also have a couple of worker servers, which will process all of these solid queued jobs. And then we have our database server, which I am running PostgreSQL. And then we have the MinIO server, which is our file storage. So this is quite the infrastructure, and setting up all of this can be a bit of a pain. Most likely you aren't going to be using something like Proxmox. However, a lot of this isn't going to matter. if you create these different virtual machines, then Kamal is pretty much going to take over. So we're going to be able to use Kamal to deploy our load balancer with an Nginx config. We'll deploy it with the application servers and the worker servers. Kamal is also going to have an accessory for the database and also MinIO. The only thing that we'll really have to shell in and set up is the Cloudflare tunnel. But even that's not too difficult. So to get started, I'm going to shell into the server, and then I want to delete everything so we're pretty much starting fresh. So I just have a script that's basically going to loop over 111 up to 118, and it's then going to call a Proxmox command to stop the container and then also to destroy it. So I'm going to go ahead and run that, and as it runs, you'll see that it's starting to stop and then delete all of the different virtual machines. And so once that's done, we then need to create all of our virtual machines. So we can go up into our containers. I'm then going to just use the same numbers that I did for everything else. And we basically have to go through and set up all this stuff. I do load in a public key for my SSH, just so I can shell into there and I won't have any problems when I'm deploying with Kamal. Personally, I do use Debian. And then we can set up all of our disks, the number of CPU cores that we want to give this machine. We can also set up the amount of RAM, which again, this server has a lot of RAM. We can give it an IP address. And just for my own personal stuff that I do, when I have a container ID of 111, then on my network, I'll just also give it that IP address 111, just so I could always easily reference to it. And then we need the CIDR, which is a 24-bit. And then we can put in the gateway address. I'll leave the DNS alone. And then that's pretty much done. And so very similar, I have a script that does all of this for me. I just had some variables that I set for the template, the swap, the password, and all of this. Obviously, I wouldn't use that password. I would use something a bit more secure. But then I have a list of all the containers, and this is going to be our container ID, the name, the number of CPU cores, the amount of RAM, and the hard drive space. And so I'm just going to go ahead and run that, and then it's going to go through and create all those services for me. And once that's done, we now have all of our servers up and running with their own configuration. And there's one other thing that I want to do. And so I'm going to copy and paste it in again, because these are all scripts that I have that I simply just refer back to. And so again, we're going to loop through all of the different containers that we just created, and then we're going to execute a command within them. We're going to run apt-update, apt-upgrade, and then we're also going to install fail-to-ban, which just basically is a protection for the network. And it's not even really something that's needed, simply because I'm not exposing anything to the internet. I'm not opening up any ports. So I'm going to run this, and then it's going to update all the packages on the servers. And that way, I don't even need to shell into each one of those to set them up. And so then I can log into Cloudflare, and I'll set up a tunnel. And again, the tunnel is basically going to be a service that we install on our network. And you basically just select what operating system you have, choose an architecture, and then you run a script. You can just copy and paste this into the server. So what I need to do is come over to my Cloudflare D. I can log right into the console. And in my case, I do need to first install curl. So I'll run apt install curl, and that'll get that installed. And then I can run everything else. And once that's installed, it should then be good to go. And then we can come over to the public host name, and then we'll set up a couple of different paths. I already have these set up, and you'll see that we have www and the domain name, and that's going to point to a local IP address, and that's going to be port 80. I also have one set up for MinIO, so we have the minio.railsenv.com, and that's going to point to the IP address and port 9000 of the MinIO server. And again, that last octet, 112, that refers back to the load balancer. And so whenever you go to www.railsenv.com, that's going to make a connection to the Cloudflare D, and that's going to proxy our connection over to the load balancer, and the load balancer will then proxy over to app1 or app2. And so that's all we had to do for the infrastructure. And so now we can come under our config deploy. I'm not going to really go into the depth of setting up the PostgreSQL within the Rails application, but we will touch on some of it within the deploy YAML. For our service name, I'm going to leave it as example. The username, I'm going to set to the user that I use. And then we can set up our web servers. So that's going to be 113 and 114. We can also set up our job servers. And the job server is going to be 1.115 and also 116. I'm going to set false for the SSL, which means we really don't need to set up our host here, but I'll just go ahead and set up the railsm.com. We'll scroll down to the registry, which that's already good. And then for the environments, I'm going to go ahead and delete or just comment out the clear with the solid Q and Puma because we do have separate job servers that will be handling that. And our architecture is AMD 64. And then we get down to the accessories, and that's where we're going to spend the bulk of our time. So for our accessories, we have a load balancer. This load balancer, we're going to use the image, and we're going to use Nginx, and we'll use the latest version. We'll set up our host. That's going to be 192.168.1.112. And we want to expose the port, and we'll expose 80:80. We do need a file for the config, so we'll have a files. On our host machine, we're just going to put that under the config/nginx.config. So that is going to be under our config folder. We're going to have another file called nginx.conf, and we'll come back to this in a few minutes. Within the Docker container, we're going to put that under the etc nginx config.d and the default.config. And that's all we had to do for the load balancer. For our PostgreSQL server, again, we're going to use an image, and that's going to be the Postgres. I'll use version 17. We'll expose a port, 5432, and we're going to expose that to 5432. We'll set up our host, and that's going to be the host IP address of that server. Notice that I'm not putting our loopback on here because we don't have just one server connecting to this. Instead, we do have multiple servers connecting to this Postgres instance now. However, because this PostgreSQL server is on our network, we can apply whatever firewall rules so everyone in the office or wherever it's hosted couldn't access it, but just on this one little network, it will be accessible to all the different servers because they are all on the same network. And we're not exposing it out to the world because we're not even going to open up any ports on our firewall. We do need to set up some environment variables. I'll have a clear one, and we'll have our Postgres_user, and we'll just set that to the example. We'll also have the Postgres_db, and we'll make that the example production. And then we'll have a secret, which the secret we do need to set up. We're just going to set that equal to the Postgres_password. In the episode that I did on Kamal and PostgreSQL, in the Kamal secrets, we had this environment variable Postgres_password, which we just ran the binrails runner, and then we got the Rails application credentials, and we just dug through to get the password. And we're going to do something very similar for that with MinIO in just a minute. We then set up our directories, and we'll just need the one for our data, and that's going to map to the var lib PostgreSQL, and then the data folder. We're then going to have one more service, and that's going to be for our MinIO, which again, we'll use an image, and that's going to be the MinIO/MinIO. We'll set up our host, and that is the 192.168.1.118. But we do need to expose multiple ports. So we cannot do ports within Kamal, and we can only have one string for the ports like this. So instead, we have to do options, and then we can do publish, and then we can list out the different ports. So we have 9000, which is going to be the main interface that we are using. And then there's also a web interface at 9001 that we can put in here as well. We are going to need some environment variables, which we will have a secret. And that's where we need to set up our MinIO root user and also the MinIO root password. We can set up the directories, and we'll have a data directory, and that'll map to the root folder and data. We can then run a command, and this command will just run the server/data, and we'll set the console-address, and we'll set that equal to port 9001. And so that's all the config that we have to do for this. With the MinIO root username and root password, we do need to come up under the secrets, and we're going to do something very similar as the Postgres password, but for the root user and the root password for our MinIO instance. So I'll just update these to maybe we'll put it under MinIO, and then we'll have a username, and we'll also have our password. Or just to kind of keep it in the same fashion, we'll have the root underscore user and root underscore password. So we do need to set those up, which we can do with a bin rails credentials :edit. And I'll just paste all this in here. With the exception, we do have one additional thing, and that's for the endpoint. And that's where we'll just put in our secure connection to the MinIO.RailsEnvironment.com. I'll go ahead and save this. We'll close it out. And we do need to set up the Nginx config now. And this isn't going to be a complete Nginx config. We're just going to have our server, and the server will listen on port 80. We'll have a location, and the location is going to be at our root. And this is where we can set some proxy information. So we'll have a proxy, set header, and for our host, we can put in our host. And there's a lot of other things that we can forward over, like the X real IP, and that's going to be the remote underscore address. We could also have the X forwarded -4, and that'll be our proxy add X underscore forwarded 4. And then we can also pass over the scheme, and that's with the forwarded proto. And then we can reference the variable scheme. And so whenever someone comes to our root location on this load balancer, we want to do a proxy underscore pass. We're going to send this to an HTTP : and then some kind of backend. This backend, you can call whatever you want. You then need to have an upstream and call it the exact same name, which we have the backend here. So this is where we'll then list out our server, and our first server is going to be the web server, is the 113 address. We'll also have the 114. And so this is your very basic setup, where any request coming into this load balancer is going to forward over the domain that you hit. And so this is going to be able to support any kind of wildcard domains that you may have for your application, as well as with the Kamal proxy. If you do have the address set up there, then you would need to forward that over as well. But it's then going to pass it off to our backend, which this upstream is then going to hit one of these two different servers. And by default, it'll just be a round robin. So we're almost done here. But we also need to set up a location for the / cable, because this is going to be for our WebSockets. We're going to do something very similar for the proxy backend, except we're going to send this over to the / cable backend. We'll also need to set the proxy underscore HTTP underscore version, and we'll set it to 1.1. And then we need to set some headers for this as well. One header is going to be an upgrade. We want to upgrade to the WebSocket, and then we can set our connection, and we can set that to upgrade as well. And then basically, I'm going to copy over these headers, and we're going to forward those over as well. And so that's all we have to do for the Nginx config. And so this is quite a bit. So I want to see just where we're at with the deployment. So I'll bring up my terminal, I'll commit everything, and then I should be ready to deploy. I'll run the Kamal setup to set up everything. It's going to first SSH into all of those servers, and it's going to make sure that we have Docker installed on them. If I were to flip back to Proxmox, we can come over and see that we are now getting a lot of CPU usage on that server. We can go through each one of the different servers to see how much memory and CPU usage each one of them have, as well as how much space on the boot disk they have. But it's doing this on all of the servers, and we can get a nice little overview of the overall health of this machine. But we'll bounce back, and we'll see where it's at. Looks like it just finished setting up Docker on all those machines, and now it's deploying the accessories, and now it's building our application to then deploy to those servers. And we can actually go to our MinIO server, port 9001, and we can put in our login credentials, because we will need to manually create the bucket. And I'm just going to call this bucket example. We'll create it, and now that's ready to go. We can switch back, and it looks like it's still building our Docker container. And just so you know, I am using the latest version of Rails, and that is version 8, release candidate 2. And we are using Kamal 2 on this deployment. But it looks like it's done building our Docker container image, and now it's pushing up the layers, and now it's deploying it to all the different servers. So it's pulling it down, it's making sure that the Kamal proxy is installed on the servers that it needs to, and it's completely done. So we can come back, and we'll just go to the railsenv.com, and we did get a bad gateway, so we do need to troubleshoot this, and it can be a little bit annoying because we have many moving parts. we have the Cloudflare tunnel, we have our load balancer, and everything else. So the first thing that I want to do is to make sure that Cloudflare D is healthy, which our example network that we have is healthy, so that's not the issue. Next up, we can come into our load balancer, which we could just shell into here. We could do a Docker container ls to see that we do have it up and running, but it is restarting. So this is most likely where our issue is. And most likely it was a typo in the config. And so after reviewing it, I did find the mistake. The listen doesn't have a colon. It's just a listen :80. Also on the proxy set header for the host, it is the HTTP host here, but that should be good. So we can commit this. And so at the top, I went ahead and pulled up the Docker container on the load balancer, and we're just watching this to see if the changes that we make fix it. So if we run Kamal, we can see all the lists of options that we have. We want to manage our Kamal accessory, so we can run the Kamal accessory, and then that gives us a few different options as well. If we run the Kamal accessory restart on the load balancer, that will send the restart command, and you see that it didn't fix the issue because it did not update the config. So we can try the reboot as well on the load balancer. That'll run, and it looks like the reboot did send over the new config. And so that's great. We can now come back, try refreshing our page, and it works. So I just had a few different typos in the Nginx config, but sending the Kamal accessory reboot on the load balancer did fix the issue. So we can now refresh this, and it doesn't show that we are hitting different servers. So let's come into our application. I'll just go ahead and close out some of this. And let's go under the app, views, welcome, and on the index page, I'm just going to get in on our shell, and we'll just display out the host name. We'll commit this, and then we can run the Kamal deploy to push our changes. Because we already had the accessory set up, it's not going to touch any of that. It's then going to build our Docker container image for the application, and it will replace both our web servers and both the worker servers. But this process should happen fairly quick because it did cache a lot of the layers because we didn't make many changes within the application itself. So it's already built out that image, and now it's deploying to those 4 different servers. You can see now it's pretty much done with it, and it's just running the health checks. Once that's done, in under a minute, we can now come back to our application, we'll refresh the page, and now you see that if we refresh multiple times, it's bouncing between the 2 different servers. So that's wonderful. It's working exactly how we would expect with the load balancing. On a side note, you may see this little save icon on the server, and this is actually a really cool feature that I love about Proxmox. So if we come back up to our data center, I have a backup schedule where it's going to run every 2 hours on every server. And basically what that'll do is on our server, we'll then get backups. So if we ever have an issue where maybe we need to restore the database or our MinIO server, we have a rolling 2-hour backup. So if something bad really happened overnight, or if we wanted to take down the load balancer, which we can just shut this down, and that's going to prevent any traffic coming in from the outside. So if I refresh the page, it's having trouble making that connection because the load balancer is turned off. So we're not able to actually hit our web application now. We could do a deployment if we wanted to. We can also take a manual backup of our database, and this then gives us a point to roll back to. So if the deployment failed and we are in big trouble, then we could always revert back to a previous image. And it's actually really easy to do. We can just come into our backup, select the backup we want to do, restore it, and it's going to do exactly what we need it to do. I've never had one of these backups fail to restore. And also another nice thing that we're able to do with these is under the resources, if we find out that maybe 4 gigabytes of RAM isn't quite enough, we can upgrade it to maybe 8 gigabytes of RAM, and we don't have to do anything. We don't have to reboot the server or anything. It'll just automatically start allocating the additional RAM. And we can verify this coming into the console. I can install htop, and then we can run that, and we'll see that now we have 8 gigabytes of RAM that the server is able to use. But back to our Rails application, we did finally get the timeout. We can refresh because we turned the load balancer back on, and we can verify that it is working. So let's add a few additional things just to make sure that this is working as we would expect. So in our Rails application, I want to generate the action_text :install, which it is going to modify the gem file. So this deployment will take a little bit longer, but we also have some database migrations. And then I want to generate a scaffold, and this scaffold is going to be for some posts. We'll have a title, and then we'll also have the content with the rich_text, just so we'll use the rich text for this. And we should be good. But before I commit it, I'm just going to go into the layouts to make a new path for the posts, and I'll make this to the posts path. But now I think we should be good to add everything. We'll make a commit, and then we can run Kamal deploy. Again, this will take a little bit longer because we are having to reinstall the gem layer, but a lot of the other layers will still be cached. And that finished in just under 2 minutes. We can come back to our application, we'll refresh the page, we'll now have our posts, and then we can create a test. We create our test, and that worked. But now, let's come back, we'll edit the test, we'll just take a screenshot, we'll copy this, we'll paste it in, and we'll try to update the post, and we got an error, and that's expected because we don't have it set up to use MinIO yet. But the database migration did trigger, and we are able to create our post. And so to set this up, we do need to modify our storage YAML file, but first I'm going to add the AWS SDK S3 gem because MinIO is an S3 compatible API. When we do go to deploy it, it will take a few minutes because it will have to rebuild that layer. But then we can come into the storage YAML file and we can start building out our MinIO service. The service will be a S3, and then we'll have our access key ID, and we'll set that equal to an ERB tag for the rails.application.credentials. We want to get our MinIO and the root_user. We're going to do something very similar for the secret, and that's just going to be the root_password. We'll then have our region, which we'll set to the US East 1. We'll have our bucket, which we did create earlier, and it was just called example. We'll set our endpoint is equal to, very similar for the secret, we had this set to the endpoint, and then we need to set the force path style, and we'll set that equal to true. We then need to come under the production.rb, and for the ActiveStorage service, we need to change this from local to MinIO. But I think that's all we have to do. We then add everything, and then we can run the Kamal deploy again. And again, this will take a few minutes. Oh, and I did have a little issue here, and we did get the deployment failed because the access key secret isn't the right key. It's actually the secret access key. But we can commit this, redeploy. It'll go through the process and redeploy again, but it will happen a bit faster. And once that's done deploying, we can come back. We'll edit our post. We'll take another screenshot. We'll copy this, paste it in. We'll then try to update it, and it worked. So we now have the MinIO working. And if we come over into the MinIO console, we'll refresh. And now we see that we have 2 objects. We can go into the object browser and we can see our ActiveStorage uploads. So that's really cool. And so next, I want to make sure that our jobs are working and they're executing as we would expect. We can do this with a bundle add the MissionControl-jobs, and then I'll add it into our gem file. We can then come under our routes.rb, and we can mount this with the MissionControl::jobs::engine, and we want to mount this at the /jobs, and we can also give it a path. We'll just call it jobs as well. So in our navigation links, we can make another reference. We can create another link. We'll just call it the jobs, and we want to send it to the jobs path. And once we commit our changes, we can run the Kamal deploy to deploy again. And once it's done deploying, we'll now have the jobs. We can go to the jobs path, and you'll see that it already processed 2 jobs for analyzing the ActiveStorage. So that worked. And so the final thing that we need to do is to verify that our action cable is working. And so we can do that with a turbo stream from, and we're just going to have a time. I'm not going to go into it too much, just because that's not the focus of this episode, but essentially, we're just going to have an ID of time that we're going to replace with the content. So we'll replace this time, which I'll just make it an empty string, and we're going to replace it with the current time. And so we'll generate a job, and I'm just going to call it the time_broadcast. Within this job, we'll simply just get our current time, and I'm actually just going to paste it in here, just because this isn't the primary focus of our episode. But essentially what we're doing is we're just using Turbo, so we don't need to create a custom channel, and we're going to do a broadcast replace to the time channel, and we're going to target the time ID. We're going to render the HTML, and it's basically the exact same HTML as before, except now we're just putting in the current time. And so this will handle our action cable, but let's make it a recurring job just so this updates. Under the config, recurring, we can add an entry. We'll just call the time_broadcast. It'll have a class, and we want to invoke the time broadcast job. We'll set this up for the queue background. And for the schedule, we want to make this happen every second. So we can save our changes, we'll commit everything, and then we'll run the Kamal deploy again. And so even though our infrastructure is a bit more complicated, where we do have our load balancer, multiple web applications, and multiple worker servers, our database, and then our storage, we're still using solid queue, solid cache, and solid cable. So that's all happening on the database. So we can verify that it deployed. We'll come back to our application. We'll refresh the page. And now we got our time broadcast and it's broadcasting. So everything is working as we would expect. We can come under the network tab. I'll refresh again. We'll have our cable channel. It did get upgraded to the WebSocket thanks to our Nginx load balancer upgrading that connection on the /cable. And then we can check to see that we are getting our streams and it's working exactly as we would expect. And so just because we are using Kamal doesn't mean that we're limited to a single server. We're able to deploy and manage multiple servers. Personally, I like using Proxmox for this, but you could do the exact same if you had multiple EC2 instances, or if you wanted to put all of this on one server. You wouldn't need the load balancer, but you could still use the Cloudflare daemon on that virtual machine with the applications installed and the background workers. And then you can also have a container for your database and also the MinIO service. And perhaps one of my favorite things about this is with the Cloudflare tunnels, we're not exposing our infrastructure at all to the whole internet. We are simply just doing a proxy into our network. Well, that's all for this episode. Thanks for watching. For more videos, check out driftandruby.com.